What's up guys, Shawnthebro here, and we're back for another episode of the fighting game tutorial series. In today's episode we are going to be going over continuing to clean up and improve our character blueprint and our character class in general. So as you probably know by now, we have been cleaning up our classes significantly, behavior, functions, variables, just so that everything is as neat as possible, because we're getting very close to doing things like rollback netcode, AI, story mode, and these very complicated things. And so as we have everything that we want to wrap up, we want to make sure that we're working with efficient code. We want to make sure that our logic isn't convoluted and we can access it and use it wherever we need to. So the character class and the NMBP were the two biggest by far, and the character blueprint is almost done at this point. I have a few more functions I want to convert to code, and we're going to continue with hurtboxes today. So hurtboxes are our static mesh components on our characters when we're in practice mode. Technically they exist all the time, but they're only visible to the user, or to the player in practice mode, so that you can see what's going on. And I've explained what these all do, but basically the colors represent the type of hurtbox, and based on the type of hurtbox, certain actions can be done to those characters at that point. So we have our push box, which is the yellow, the throw box, which is the blue, and then the different type of hurtboxes for damage, which are the green ones. And we can have a few other types as well. In the last few episodes, we converted to being able to modify the position and the size of the hurtbox in the code, and this worked for the simple hurtboxes and the complex hurtboxes. Before this point, this was entirely blueprint logic, and now we can change it right from the code, just like we should be able to do in our game. Another thing that we should be able to do in the code is to spawn these hurtboxes, so call the functions that set up all the logic that we did in the previous episode, or converted in the previous episode. And we should also be able to do what's called despawn hurtboxes, but really this is more like make hurtboxes inactive so that we can set the hurtboxes up again. So I want to take both these functions that are in our character BP, and I want to remove them from the character BP and instead put them in the character class, the C++ class. That way they're more efficient, and then all the hurtbox logic is residing in the same spot for the character. There'll be a few other improvements in our character class as well, but you'll see even as we go into this class, this list is significantly smaller and the graph is significantly smaller as well. Most of this logic is just for keyboard mode inputs, so when you take that out, the vast majority of the behavior is now in the code, which is a wonderful change. Now with that said, we can go ahead and get started, but before we do, if you want to get caught up in the entire series and check out how we've done everything in our fighting game tutorial series, such as our hitboxes, other episodes on our hurtboxes, our projectiles, our movement, and a whole lot more, I'll link you to the entire fighting game tutorial series right here in the top right corner. Alternatively, if you don't care about that and you only care about the hurtboxes or cleaning up a character blueprint or having a clean character class for your game, you're still in the right spot. I recommend you check out this episode, which is the previous episode where we converted more of our behavior for our hurtboxes from blueprints to code, because once you see how we did that, it's going to be very easy to follow it up with this episode today. With that out of the way, we can go ahead and get started. So again, this is a code and blueprint tutorial series. We're going to be cleaning up our character class, so we're going to be doing a little bit in blueprint, a little bit in code, but mainly we will be removing functions from blueprint and putting them in the code, which is making it more efficient. So if we go to our character blueprints, so blueprints, character BPs, and specifically our base character BP, this is our class that we want to clean up here. And in here, I mentioned the spawning of the hurtboxes and the despawning of the hurtboxes. So spawning hurtboxes is a function that we messed with in the previous episode. It was significantly more convoluted than this previously because we were calling separate functions to do different behavior based on the game mode type, and we could only call them if the character had hurtboxes of certain types. Now we can choose exactly what we want in these functions. However, this function could also be easily converted from blueprints to code, so we'll take care of this one today. And then additionally, the despawn hurtboxes, or as I was mentioning in the intro, it's essentially just setting the hurtboxes back to an inactive state. So they're not listening for collision, they're not visible, but we don't outright delete them or destroy them or anything. We were just clearing them out of the array so that when we call spawn hurtboxes, which calls set up hurtboxes, which is now a code function, we're just finding the appropriate hurtboxes on the character and setting up their default values. Now even this is a bit overkill in my opinion, When we're despawning the hurt boxes and we're just making them inactive, we don't really need to set them up again afterward. We can just choose if they're active or inactive and set their visibility. And we also don't need to do it for both the simple hurt box and complex hurt box array. We can choose which one to do it for, or if we want to do it for both, just like we were doing in our setup hurt boxes function, where we now have booleans for if we're using simple hurt boxes or complex hurt boxes, and we can technically use neither or both, and all those cases are supported in our game. So long story short is we have a few things to clean up in both of these functions, but by the end of this episode, they're both going to be converted to code. They're going to be cleaner, and they're going to have more options as well. So when we're ready, we can go ahead and go into our code, and specifically we want to go to our fighter template character class. So fighter template character.cpp and fighter template character.h. In fighter template character.h, we can scroll down to where our functions are, or our variables are for hurt boxes. I'm going to go to where we made the functions for our hurt boxes in the previous episodes, and I'm going to go above them and make a new function. For this first one, this is going to be our spawn hurt boxes. Now, spawn hurt boxes really isn't spawning our hurt boxes. It's choosing which set of hurt boxes we want to use, which again is now our code function. And based on the boolean that comes in here, we find the hurt boxes of the given type, add them to the array, which allows them to be actually properly tracked, and then we set the visibility of them. So it's not really spawning hurt boxes, it is more finding the hurt boxes that we've set up on our character and determining which ones to use. If you want, you could rename the function because of this. I'm going to put the comma as determine which set of hurt boxes, say which sets of hurt boxes to use, if any. And we'll make it ufunction blueprint callable, so we can call it from the blueprint. This is definitely going to be done in our blueprints before because it was a blueprint function, so we're still going to support that. And we'll call it void determine hurt boxes to use. Okay, and this is going to be our spawn hurt boxes equivalent. If you want, you can call it spawn hurt boxes. Then for the other one, we're going to leave a comment that says deactivate the specified sets of hurt boxes. And we'll make it ufunction blueprint callable for the same reason. This is definitely going to be blueprint callable in our game currently because it was a blueprint function previously. We'll make it void disable hurt boxes by complexity. And actually, let's change the name of this. Determine hurt boxes to use by complexity. I like being very explicit with what we're doing here. So this isn't just the type of hurt box like throw box, push box, damage hurt box. We're really determining which hurt boxes to use by their complexity, simple or complex. And same with here. We're not really disabling them or despawning them, as we were calling it in the blueprint, based on their type, but rather their complexity. Now we have our two functions that we're going to convert, so we can go to the fighter template character.cpp. Then we can scroll down to where we want to make these functions. I know I want to make them right above our setup hurt boxes function. So this is the perfect spot. We can type void a fighter template character : determine hurt boxes to use by complexity. Then we can make our other function void a fighter template character : disable hurt boxes by complexity. Now, as you can see, spawn hurt boxes takes in no parameters and it doesn't have a return type, so we set that up correctly. And despawn hurt boxes takes in no parameters and also doesn't have a return type. So all of this is good. Now we can just start porting over the logic into these functions. So remember, determine hurt boxes to use by complexity is essentially spawn hurt boxes. Set up hurt boxes is doing all the real work here. This function is just determining how we're going to call this function. And in the blueprint, what we were doing is checking to see if we were using complex hurt boxes in the game mode, or if the entire game was set to be a 3D fighter. So if the game is set to be a 3D fighter, we assume that we want to use 3D hurt boxes by default. However, we also support using the complex or the 3D hurt boxes in the 2 and 2.5D fighter if we prefer that method. So I allowed support for both in the series. That just means we need to check for both these things in the code if we want to have this logic one-to-one. So the first thing we need to do is get the game mode and the game instance. Now we're in the fighter template character, so we can easily grab both of these. If a fighter template game mode pointer game mode equals cast, and we're going to cast to our type a fighter template game mode. Then in parentheses we're going to put get world get auth game mode. So we're getting the world, which is essentially the level or what is active right now in the game, and then we are getting the auth game mode or the authority game mode, which means the game mode the server is running in single player with the server. So we're just getting the game mode essentially. We're casting it to a fighter template game mode, which is the type that we want to check against because this is our game mode. This is the class that has the variable for is using complex hurtboxes, which we're using right here. So we don't have a reference to the game mode in the character class like we do in the game mode BP. You could definitely add one if you want, or we can just check the game mode here like this. If this cast returns successfully, it means it found the game mode and it was able to cast it to this type, so it sets it into this variable. If this variable isn't null pointer, meaning it was set, we'll go into the if statement. Then we're just going to do the same thing again, except for the game instance. So if u base game instance pointer game instance equals cast u base game instance, and we're going to be casting get game instance. So you can get the game instance, the active game instance, and cast it to our type, and if it succeeds it will be put into this variable. Again, the if statement will then succeed and will go into here. At this point we can just grab our two variables, our two conditionals that we want to check here. So we want to check is using complex hurtboxes from the game mode and is fighter mode 3D for the game instance. If game mode is using complex hurtboxes or game instance is fighter mode 3D, and if either of these conditions are true, then we want to call setup hurtboxes passing in is using complex hurtboxes as true and is using simple hurtboxes as false. So set up hurtboxes, and we want to pass in false for is using simple hurtboxes and true for is using complex hurtboxes. Else, if both of these conditions were false, then this or will fail. We'll go into this else, and at that point we want to call setup hurtboxes again, but this time we want simple hurtboxes to be true and complex hurtboxes to be false. Perfect. Now we can go to despawn hurtboxes, and we want to do this logic in here. So this is our other function, our disable hurtboxes by complexity. And in this case, we did not have parameters, but we may want to check for the same thing instead of just disabling all of them, both the simple and complex. With that said, if we haven't activated the simple hurtboxes and we're using complex hurtboxes, this array will be empty. So when we try and loop through it, it will complete essentially immediately. And so it's perfectly safe to do it this way too. For simplicity's sake, I'll just go ahead and copy this. So we want to use our simple hurtbox array and we want to loop through it. So we can either use a regular for loop or for each loop. So essentially we can do our for int I equals 0, I is less than simple hurtbox array dot num plus plus I, or we can do our new for loop that I showed you in the previous episode, where we make a static mesh component of the element at the index. So use static mesh component pointer, we'll call it hurtbox colon simple hurtbox array. Either way is perfectly fine. I like to use both. I do like to be consistent though, and since we were using this type of for loop for the hurtboxes, I will keep doing that. So for use static mesh component simple hurtbox colon simple hurtbox array. So this is just creating a for each loop essentially. For each index, we want to set them to be inactive and hide them, so set their visibility to be false. So simple hurtbox set active, and the parameters are if it is active, which is going to be false, and if we need to reset this, which is also going to be false. So we can just put false, false in here. Now make sure we set visibility to be false for new visibility and propagate to children. This could be false or this could be true. None of my hurtboxes have children, so I don't need to propagate to them. Even if they did in this case, as long as I add them to this array by using the naming convention, which I have been doing, this method would still work. But if you want to have children hurt boxes that aren't in this array, or just children of your hurt boxes that aren't in this array, then you would want to set propagate to children to true. So just keep that in mind, but we can set simple hurtbox set visibility to be false and false. Technically, the propagate to children is a default parameter, and I believe so is the reset. So you could just also do set active false and set visibility false. And simple enough, we've already managed all this in the code. Now after this loop is done, we were clearing the simple hurtbox array as well, removing all the elements from the array. We're not deleting the hurt boxes. They're still active and we can re-enable them when we call setup hurt boxes again. The reason we were clearing them is because in setup hurt boxes, or when we were doing this in our blueprint, we were adding the hurt boxes based on a bunch of variables that we set up in the previous episode, that we set up many episodes ago, we converted in the previous episode. And so if we didn't clear this array, then we were just adding duplicate entries in here. It's fine, we can clear it and just re-add it, but another method is simply to set them to be active and visible based on if they're active or not, and not remove them and add them to the array every time you want to do this. So just keep that in mind. You have a few options, but simple hurtbox array, it is not clear in C++, it is empty, so .empty. Clear / empty the tracked hurtboxes. And we'll add a comment here, hide or disable and hide all simple hurt boxes. Now after this, we just have to do it for the complex hurt boxes as well. It's the same process, so we can essentially do the exact same thing here. For static mesh component pointer complex hurtbox complex hurtbox array, and disable and hide all complex hurtboxes. So complex hurtbox set active is false, and complex hurtbox set visibility is false. Clear / empty the tracked complex hurtboxes. Complex hurtbox array .empty. Now we've copied over all the logic from the despawn hurtboxes function. So at this point we're ready to test. I am going to make this consistent as well because I wasn't. So put these in quotes just so anyone looking at this code knows what I mean. Our simple hurtbox type and our complex hurtbox type. Don't want to be confusing, right? And then I'll also add a comment here, set up complex hurtboxes. Set up simple hurtboxes. There we go. Now we have our functions ready, so at this point we're ready to launch the game again. Once the editor is back open, we can go back into our base character BP, so blueprints, character BPs, base character BP, and we can start removing spawn hurtboxes, but before we do this, let's make sure it's not being used anywhere else that we're not aware of. So we can right click on spawn hurtboxes and find references, and then we can see our two function calls in base character BP, and nowhere else in here. Let's use the binoculars. We can see it's not used in any other files, so we are safe to assume that these two are the only places that we were calling spawn hurtboxes. So if we go to the first one here, it is in event begin play of our base character BP, and it's after we set up our player 2 character for keyboard input. This is the first one we should replace with our new function. And we can see that the other one is right here in reset hurtbox complexity, which is when we're going from 2D to 3D mode or vice versa. And you can see we call it in here as well. So both of these are going to be replaced with our new function. And we're also calling despawn hurtboxes in this event as well. So we'll take care of all of these. Let's start with the one in begin play, and let's instead call determine hurtboxes to use by complexity. Hook it up the same way spawn hurtboxes was hooked up. And you can remove spawn hurtboxes, maybe make some room for this new node. And something like this will do the trick. let's make sure we replace it in the other section as well. Use our new function in here and just hook it up the same way. And then once you've done this, you can make sure to play your game and ensure that the hurt boxes are working as expected. So if we come into our game specifically practice, we should be able to attack our opponent and register damage. If so, simple hurt boxes are set up properly, and then we can change to our 3D hurt boxes with our console command. Damage for these guys isn't actually set up yet for the 3D fighter, but we should be able to swap through it, see the hurt boxes there, then swap back and see the simple hurt boxes working again. So now that we verified that that is working, we can go on to removing despawn hurt boxes. So you see I just deleted the spawn hurt boxes function from the base character BP, and now we're going to find the references on despawn hurt boxes. So right click on it, find references. Then we see that this is the only place it is called. I know for a fact it is not used in any other blueprints, but feel free to check, make sure that you check. And then once we know this, we can change it out for disable hurt boxes by complexity. Then once we've done that, make sure to test it again and do the same tests. So load up practice mode, attack your opponent, make sure that damage is going through, make sure collisions are occurring. Switch to your 3D fighter. We don't have collisions working yet, but we should see those hurt boxes. Then we can switch back to the 2D fighter and we should see the damage and the collisions occurring again. Once we've done that, we've verified that our logic was successfully converted, and now we can also remove the despawn hurt boxes function from the base character BP. Make sure to compile and save the blueprint after that, and you'll be good to go. I hope you guys enjoyed this episode on cleaning up your character blueprint and your character class in general. It's always a fun time to do this, but it's also making our game more efficient and easier to manipulate in the future. If you enjoyed and you want to support the channel, then please subscribe. It is completely free, and it does more for myself and the channel than anything else you can do. So I really appreciate it. If you'd like to give more support to myself and the channel, you can also check out the Patreon, YouTube membership, and Discord subscriptions for added benefits. Thank you so much to all the kind souls who already have. You guys are amazing. If you ran into any problems while following this tutorial or any of my tutorials, feel free to join the Discord community. There is a link in the description, and that support is completely free. Thank you so much for watching. I'm Shawnthebro, and I'll see you in the next one. Goodbye, guys.